All right, let's dive into a real cosmic mystery. We're going deep into our galaxy to investigate a whodunit that had astronomers scratching their heads for years, a secret that was hiding in plain sight, right inside the family portraits of the stars.
So imagine you're looking at a family photo. All the siblings were born at the exact same time from the same parents. But for some reason, they've split themselves into two totally separate groups in the picture. That is exactly what astronomers found when they looked at star clusters, and it broke all the rules they thought they knew.
Now, to really get a grip on the mystery, you first have to understand the crime scene. For decades, astronomers had what they thought was a really simple, straightforward story about these places we call open star clusters. Think of them like stellar nurseries. You've got a whole bunch of stars all born together from the same giant cloud of gas and dust. This means they all have the same age and the same chemical recipe, which makes them the perfect controlled environment for testing our theories about how stars work.
So here's the crucial point. When you plot all those stars on a chart, they should all fall neatly along a single predictable line. One big, happy, and really orderly family. At least, that was the theory. But, as it always seems to happen in science, as our telescopes got better and our vision got sharper, that simple story started to completely fall apart. The evidence was pointing to something very strange.
The key tool for this whole investigation is something called a color magnitude diagram. And honestly, you can just think of it as the astronomer's version of a fingerprint chart. Every star has its place. And for most of their lives, stars hang out on this clean, beautiful line called the main sequence.
So armed with this powerful tool, astronomers pointed their new super-powered telescopes at young star clusters, like one called NGC 2287. And what they saw, it just seemed impossible.
And here it is. This is the heart of our mystery. Instead of that one clean line they expected, there were two totally distinct main sequences running parallel to each other. It's like that single family had suddenly split into two competing households. How on earth could stars, born from the same cloud at the same time, end up in two different places?
Well, the investigation kicked off immediately. And these detectives of the cosmos, they quickly zeroed in on a prime suspect, a really fundamental property that every single star has.
The leading theory was that the spin of the stars was somehow messing everything up. See, a star that's spinning really fast bulges out at its equator, which actually makes it look a little bit redder and fainter than a star that's just sitting still. So the question was, could this be the answer?
And this is the moment the case just blew wide open. Astronomers went and measured the rotation speeds of the stars on each of those lines, and the evidence was just undeniable. The stars on that bluer sequence, they were all slow rotators. And the stars on the redder one, you guessed it, they were all spinning incredibly fast. And just to give you a sense of the kinds of speeds we're talking about, one of the fastest stars they clocked was whipping around at 322 kilometers per second. That's over 700,000 miles per hour.
The difference was really stark. The average speed for the blue family was about 111 kilometers per second. For the red family, it was more than double that, clocking in at 255. So the mystery of the two lines was solved, right? Well, not quite. It was really a mystery of two speeds, but that just raised a whole new question.
Why would stars born in the exact same stellar nursery end up with two completely different spin rates? This case needed one final twist, the revelation of an unseen partner in this cosmic crime.
See, the general thinking is that most stars are actually born spinning pretty fast. So the real puzzle wasn't the fast spinners, they were normal. The real question was, where did all the slow ones come from? Something had to be hitting the brakes.
And that cosmic brake has a name. It's a process called tidal locking. It's the very same force that makes sure we only ever see one side of our moon. If a star has a close companion, like another star orbiting it, the gravity from that companion can literally tug on it, slowing down its spin over millions and millions of years.
So let's just walk through this whole sequence of events. Okay, so a star is born, it's spinning like crazy, which puts it on that red line. But if it happens to have a small, unseen companion star orbiting really close by, that companion's gravity grabs hold and starts to slow it down. Over time, it becomes a slow rotator, and its appearance on that fingerprint chart shifts right over to the blue line.
And case closed. The slow spinners weren't a different species of star at all. They were just fast spinners that got slapped in cosmic handcuffs by a binary partner.
The two families were really one and the same, just caught at different stages of a gravitational dance.
Now, solving this mystery in one star cluster was a massive breakthrough, but it immediately opened up a much, much bigger question. Just how many other star clusters out there were hiding this exact same secret?
I mean, manually checking thousands of clusters for this effect? It would have taken lifetimes. But we happen to be living in an absolute golden age of astronomical surveys. And we have new tools that can do the work of thousands of astronomers, all automatically.
The absolute game changer here is the Gaia Space Telescope. It has mapped the precise positions and movements of nearly 2 billion stars. It's just an incredible amount of data. And by feeding this massive data set into machine learning algorithms, astronomers can now identify the true members of any star cluster almost instantly. And this new approach is revealing these secrets everywhere we look. I mean, just look at the power of this. In a matter of minutes, a survey can identify over 1,700 members in NGC 2099, or 1,400 in M67. And what about Messier 41, the beautiful cluster known as the Little Beehive? Thanks to this, we now have a confirmed list of 783 probable family members. And just to put that on the map for you, that cluster, M41, is about 2,360 light-years away from us in the constellation Canis Major. And thanks to this new stellar census, we can finally conduct a proper investigation, sorting the real members from the imposters to see if it too is hiding the secret of the split stars.
And that is what's so exciting about all of this. This entire cosmic whodunit, once a fundamental puzzle, was not only solved but is now being explored all across the galaxy. It really makes you wonder, with these unbelievably powerful new ways of seeing the universe, what other incredible secrets are just sitting right there in front of us, waiting for the right moment to be revealed.